Guys, there is some issue with chat option. So if you get the answer, then please unmute the mic and let me know the answer. Should we discuss the solution? Yes, Yash, it is correct. Okay, let's discuss the solution now. But before that, let's see how to find a projection of any vector on some vector, given vector. So if this is B vector and this is A vector and the angle between them is theta, then the projection of B on A will be this. So projection of B vector on A vector is mod B cos theta, which can also be written as A dot B upon mod A. As the direction is this A vector. Now the A vector is given in the question as I cap plus j cap plus root 2 k cap. B vector is given as b1 I cap plus b2 j cap plus root 2 k cap, and C vector is given as 5 I cap plus j cap plus root 2 k cap. Now it is given that the projection of B on A is equal to A. So if I find it, then A dot B upon mod A is given as mod A. So what is mod A? Mod A is root 1 plus 1 plus 2, which is 2. Under root of 4 is 2. So A dot B can be written as 1 into B1, B1 plus 1 into B2, B2 plus 2 equal to mod A square. So this becomes 4. So B1 plus B2 comes out to be equal to 2. Now it is also given in the question that A plus B is perpendicular to C. Now as soon as you come across this thing that a vector is perpendicular to C, the first thing that should come into your mind is that A plus B dot C will be equal to 0. So now A plus B dot C will be 5B1 plus 1 plus B2 plus 1 plus 4 equal to 0. So this becomes 5B1 plus B2 plus 10 equal to 0. And I already knew that B1 plus B2 equal to 2. So if I take this as equation number 1 and this as equation number 2, I can solve these to get 4B1 equal to minus 12, which means B1 equal to minus 3. And if I put this B1 here, I get B2 equal to 5. So B vector is minus 3 I cap plus 5 j cap plus root 2 k cap. So I had to find the modulus of B. So it is 9 plus 25 plus 2, which is root 36, which is 6. So I hope you understood the solution. Okay, so let's move on to the next question. This is the question. Let A vector equal to 2 I cap plus lambda 1 j cap plus 3 k cap. B vector is given as 4 I cap plus 3 minus lambda 2 j cap plus 6 k cap. And C vector is given as 3 I cap plus 6 j cap plus lambda 3 minus 1 k cap. These are three vectors such that B vector equals to 2A vector and A vector is perpendicular to C vector. Then a possible value of lambda 1, lambda 2, lambda 3 is. Yes, Ruben and Nishchay, your answers are correct. Okay, so let's discuss the solution now. question, A vector is given as 2 I cap plus lambda 1 j cap plus 3 k cap. B vector is given as 4 I cap plus 3 minus lambda 2 j cap plus 6 k cap. And C vector is given as 3 I cap plus 6 j cap plus lambda 3 minus 1 k cap. Now it is given that B vector is equal to 2A vector. So B vector will be equal to 2 times of A vector, which is 4 I cap plus 2 lambda 1 j cap plus 6 k cap. Now B vector is already given as this. So if I compare these A, B, C in both these B vectors, I'll get 4 is 4. Okay, well that's fine. 3 minus lambda 2 will be equal to 2 lambda 1 and 6 is equal to 6. Okay, so now 3 minus 2 lambda 1 will be equal to lambda 2. Now what is the other thing given in this question? It is given that A is perpendicular to C vector. And as I told in the previous question, that whenever you come across this statement, the first thing that should come into your mind is that A dot C will be equal to 0. Now what is A dot C? A dot C will be equal to 6 plus 6 lambda 1 plus 3 times lambda 3 minus 1 will be equal to 0. So this is 6 lambda 1 plus 3 lambda 3 minus 3 plus 6 equal to 0. So from here we get 3 lambda 3 equal to 6 minus 3 will be 3. This will become minus 3 minus 6 lambda 1. So lambda 3 equal to minus 1 minus 2 lambda 1. So now I know lambda 2 and lambda 3 in terms of lambda 1. So now let's put the options here. What are the possible values of lambda 1, lambda 2, lambda 3? Lambda 1, lambda 2 was 3 minus 2 lambda 1 and lambda 3 was minus 1 minus 2 lambda 1. So if I put here 1, then lambda 1 is 1, okay. Then lambda 2 will come out 1. So option A is wrong. If we check with option B, then lambda 1 is minus 1 by 2. Lambda 2 will become 3 minus 2 into minus 1 by 2. So this is equal to 4, okay. And lambda 3 will become minus 1 minus 2 into minus 1 by 2. So minus 1 plus 1 is 0. So the correct option is option B. So is this solution clear to everybody? Are there any doubts? Yes, okay. Let's move on to the next question. Let A be a point on the line r vector equal to 1 minus 3 mu I cap plus mu minus 1 j cap plus 2 plus 5 mu k cap and B 3, 2, 6 be a point in the space. then the value of mu for which the vector AB is parallel to the plane x minus 4y plus 3z equal to 1 is. Yes, Kritika, it is correct. Yes, Shreyas, it is correct. No, no, sorry. It's not correct. Check it once again. Okay, there is some minor error. Let's discuss the solution, then you'll get it. It is given that A is a point on this line and B is some point in the space. Then we have to find the value of mu for which this vector AB is parallel to the plane x minus 4y plus 3z equal to 1. But by this equation of plane, I can say that the vector normal to this plane is I cap minus 4j cap plus 3k cap. Okay, so I got this from the question. Now let's solve it. So if this is a plane, I know the normal vector. I consider some point B in space, which is 3, 2, 6, and A point is here on the line, okay. Now it is given that this AB vector is parallel to this plane. So if AB is parallel to this plane, then obviously AB is perpendicular to this normal vector. So if AB is perpendicular to this normal vector, then I can say that AB dot n will be equal to 0. Okay, so let's find out. Now A is on the line r vector equal to 1 minus 3 mu I cap plus mu minus 1 j cap plus 2 plus 5 mu k cap. Now I can find this AB vector by doing B vector minus A vector. So B vector is 3 I cap plus 2 j cap plus 6 k cap. So if I subtract A from this, A will be this 1 minus 3 mu I plus mu minus 1 j and 2 plus 5 mu k cap. So this is 3 minus 1 plus 3 mu I cap plus 2 minus mu plus 1 j cap plus 6 minus 2 minus 5 mu k cap. So this AB vector will be 2 plus 3 mu I cap plus 3 minus mu j cap plus 4 minus 5 mu k cap. And what I know that AB dot n vector is equal to 0. And what was n vector? N vector we got from the equation of the plane. It was I cap minus 4j cap plus 3k cap. Now just we have to take the dot product of these two vectors and we'll get the value for mu. So the dot product is 2 plus 3 mu into 1 plus 3 minus mu into minus 4 plus 4 minus 5 mu into this 3 and this should be equal to 0. So this is 2 plus 3 mu plus 12, sorry, it is minus 12 2 plus 3 mu minus 12 plus 4 mu plus 12 minus 15 mu equal to 0. So this is 3 plus 4, 7. This is minus 8 mu equal to minus 2. So mu equal to 2 by 8, which is 1 by 4. So this question involved the concept of this normal vector. If you know this concept, then you must have solved the question. I hope everybody understood this solution. Is it clear to everybody? Okay, so let's move on to the next question then. This is the question. Let alpha vector equal to lambda minus 2 a vector plus b vector and beta vector is 4 lambda minus 2 a vector plus 3b vector. These are the two given vectors where vectors a and b are non-collinear. So the value of lambda for which vectors alpha and beta are collinear is. Yes, Kritika, it is correct. Okay, so let's discuss the solution now. Okay, we'll discuss the solution, then you'll get to know the answer. Fine. Alpha vector is given as this, beta is this. We have to find where alpha and beta are collinear. So when alpha and beta are collinear, that means that alpha will be have to be some x into beta vector. This can be 2, 3, 4, 5, anything. So let's write it now. What was alpha vector? Alpha vector was lambda minus 2 a vector plus b vector, and beta vector was given as 4 lambda minus 2 a vector plus 3b vector. Now we know that they are collinear, so they will satisfy this condition. So I'm taking x because it is nowhere in this. So lambda minus 2 a vector plus b vector equal to x times 4 lambda minus 2 a vector plus 3x into b vector. Now it is given that a and b are non-collinear. So if A and B are non-collinear and this has to be equal, then this is possible only when coefficient of A is equal to coefficient of A here and coefficient of B here is equal to coefficient of B here. So the coefficient of B here is 1, it is equal to 3x. So this implies that x equal to 1 by 3. And now let's check for coefficient of A. It is lambda minus 2 equal to 1 by 3, 4 lambda minus 2. We put the value of x in this. So it is 3 lambda minus 6 equal to 4 lambda minus 2. So this is lambda equal to minus 4. So the correct option here was option D, minus 4. Okay. Yes, Shreyash, it was D. So I hope this solution is clear to everybody. Are there any doubts? Is it clear to all? Okay. So this was all for today's class. See you in the next lecture. Thank you.